Hi, welcome to Learning Algebra from Scratch, a course from ultimatealgebra.com. Addition and subtractions in algebra. We can only add things if the letters and their exponents following them are exactly the same. Example: we can add 2x and 3x because they both have x following the numbers. All you do is add the numbers and bring the common letter after the number. So we added the 2 and the 3 to get 5. Then we brought the x after it. The final answer is therefore 5x. Example 2. If you have 2x plus 3y, you cannot add them because they have different letters after them. One is y and the other is x. Example 3. If you have 2x squared and 3x cubed, you cannot add them because of the different exponents. One of the x is squared and the other is cubed. Example 4. You cannot add 3ab plus 2ac. Although they both have a, one is ab and the other is ac. They must be exactly the same before you can add them. Let's try these. 5ab minus 2ab. Here, since they both have ab after the number, we can subtract. This gives us 3ab. As you can see, if your addition and subtraction is good, this should be easy. Addition and subtraction of multiple terms. Like the way we added multiple numbers in basic math, we might have to add multiple terms in algebra. Let's try this. 2ab plus 5bc plus 3ab minus 2bc. Here we take the first term, 2ab, and find out if there are other terms with the same letters after it. We notice we have 3ab, so we can add 2ab and 3ab to get 5ab. Next, we pick the 5bc. We look for another term with bc. Here we have negative 2bc. We work on 5bc minus 2bc to get 3bc. We cannot add 5ab and 3bc since they have different letters after them. So that is our final answer. The invisible 1. Let's look at the invisible 1 in algebra. Example: AB is the same as 1AB. This means if we have just letters without a number in front, the invisible 1 is assumed. Example: 2AB plus AB equals 2AB plus 1AB, which equals 3AB. Again, 3AC plus AC will be equal to 4AC because AC is the same as 1AC. Multiplication and division. We are now familiar with addition and subtraction in algebra. Please, I hope you have mastered it because it is a step-by-step course and we have carefully chosen the trend to make you good in algebra. I'm sure you can do these. What is 2 times 3? What is 5 times 6? If you had 6 and 30, we are good to go. If you are not good at multiplication, you can either learn them later by memorizing the multiplication table or deriving it, or watching our videos on math tricks for multiplication. Multiplication and division of negative numbers. The real problem in most cases is when negatives are introduced. When you multiply a negative and a positive number, the answer is always negative. Example, -2 times 3 equals -6. 5 times -6 equals -30. Notice, in both cases, one is positive and the other is negative. Now, let's look at when you multiply two negative numbers. When you multiply two negative numbers, the answer is always positive. So we say -2 times -3 equals 6, and -5 times -6 equals 30. The exact same idea applies to division. We say -6 divided by -2 equals 3. Notice, we worked with two negative numbers and our final answer is positive. When we divide -6 by 2, we get our final answer to be -3. Here, one of the numbers is negative and the other is positive. 6 divided by -2 will give us -3. Here again, one of the numbers is positive and the other is negative, so our final answer is negative. Please pause this video and make sure you are familiar with the multiplication and division of negative numbers before we move on. Multiplication and division in algebra. When we learnt addition and subtraction in algebra, we said that letters must be exactly the same before you can add or subtract them. Example, we can add 3A and 2A because both have the same letters after the number. We also said we cannot add 3A and 2B because the letters are different. For multiplication and division, it doesn't matter the letters. You can always work on them. Example: 6ab times 2ac. The first thing you'll do is multiply the numbers just like we did in basic math. Multiply the 6 and the 2 to get 12. Now for the letters. We just look at the number of occurrences. Here, we can see that there are 2 a's. So we have a exponent 2. There is just one b, so we have b here. And we also have one c. Easy, right? Let's try these. Negative 3ab times negative 2bc. Here we multiply the negative 3 and negative 2. These are both negatives, so we have positive 6. Next, we look at the occurrence of the letters. The A occurs just once. The B occurs twice. And the C occurs once. So our final answer is 6ab squared c. When dealing with a lot of multiplications, please work on them from left to right. This is not a mathematical requirement. This will just make it consistent with operations like division and subtraction that require that order. Example: negative 2a times 3ab times 2b. Here, we will do the negative 2a times 3ab first to get negative 6a squared b. Then, we'll multiply this by the 2b to get negative 12a squared b squared. Division in algebra. In division, we are still looking at occurrence, but in a slightly different way. Let's look at 6a squared b divided by negative 2ab squared. I will encourage you to write it in the fraction form. It is easier. We divide the numbers as usual. We divide the 6 by negative 2 to get negative 3. Now we say there are 2 a's at the top and 1 at the bottom, so there will be 1 left at the top. There is 1 b at the top and there are 2 at the bottom, so there will be 1 left at the bottom. What we are actually doing is this. A squared is the same as a times a. So we are just splitting the exponents and canceling the common letters. Notice that we did the same for the b. After the cancellation, we notice that we have 1a at the top and 1b at the bottom. Let's try another example. Here we have 15x squared y exponent 4 divided by 5xy exponent 6. First, we divide the 15 by the 5 to get 3. Next, we notice there are 2x at the top and 1 at the bottom. So our answer will have 1x at the top. Also, We see there are 4 y's at the top and there are 6 y's at the bottom. So there will be 2 y's left at the bottom. So this is our final answer.